Hey guys, welcome back, and today I'm going to talk to you about predicates and quantifiers. So in the past videos in implications and bidirectionals, we talked about propositional logics. So those logics would always generate an either true or a false value. However, that's not always the case in real world. For example, in situations like x plus 3 equals to 4, we cannot come up with a true or a false value because we don't know what the value of x is. So for situations like this, we have to use predicates. So rather than using the definitions of predicates to understand them, let's go into an example so it's easier to relate to it. So for example, x implication 3, meaning if the value of x is 3, then the result would also be 3, so thus generating a true value. However, we don't know the value of x. That's why we are using predicates here. So to use predicates, we have to put this equation into a function. So let p of x be x implication 3. Now for some values of x, this equation would be true, right? So some values of x would generate an either true or a false value. So p of 4 would be false, whereas p of 3 would be true. So let's move on to quantifiers and let's see how predicates are used there. Okay, so in quantifiers, so there are two types of quantifiers. So let's write that down. One is universal quantifier, another one is existential quantifier. So the most important thing here is to remember the symbol, which is an A which is inverted and an E which is like in the opposite side. So let's try to understand quantifiers with another example, because I believe examples would help you understand better than definitions. So let's look at a question here. X squared is greater or equal to 0. Quantify So how do we quantify this? As I said before, there are two types of quantifiers, right? So one is universal, another one is existential. So we use universal quantifiers in places where for all values of x, we would get the true or a false value. So to represent all values, we use universal quantifier, and to express some values, we use existential quantifier. So in this case, what does it tell you? So for all the values of x, it would be either equal to or greater than 0, right? So for 0 it would be 0, for 2 it would be 4. So anything that you put into it, even minus values, it would always be greater than 0. So for all values of x, this situation would always be true. So let's quantify this right now. So we use the universal quantifier sign, and so this is the universal quantifier sign, and then here we put x because the function takes values of x. That's why x representing that all values of x would be something true or false. Universal quantifier, and then write the function. So ax. So one thing I forgot to mention before, so to quantify something we have to use predicates first. So in predicates we make the function, we make the equation into put the equation into a function, right? So that would be ax equals to x squared divided by 2, right? So that's what we are getting here. So finally, let me tell you what just happened here. So this is the question we were asked to do, and so from the looks of it we can understand that for all values of x we always get a positive value here. So for all values of x we used ax because of we are putting values in the x. Now then we just use the function here. So thus this equation is quantified. So questions from this chapter, this topic is kind of complicated sometimes, so we would be going through some examples here. However, before going through some examples, we would try to understand what this and this means in different situations. So let's write down some equations, quantifiers. Let p of x be another function, right? So this is one example, this is another one. So let's get into all of these and explain what these actually mean. So this is the existential quantifier. So for some values for some values of x, p of x is true. So let's try to explain this from the top. So this represents an existential quantifier, right? So for some values, so we know from the chart before that existential quantifiers mean for some values. So here we have written for some values of x, this equation is true, which also means that for some it's false. Again, so not for some values, this is again e of x, ex, so I'm just gonna say e, and for this I'm gonna say a, so it's easier for you guys to understand. So for some values of x, so for some values of x, p of x is true. However, there is a not sign before, so for not for some values of x, p of x is true. So that means that for some values of x, that might be false, right? So not for some values of x, p of x is true. So for some values of x, p of x is false. So coming up to the next one is not for all values of x, a of x is true. So anything that you put into the function is never gonna generate a true value. And this one is for all values of x, a of x is never true. So this is kind of similar to this, the first one. because I would go back to that once more. However, let's look at the last one. So for all values of x, a of x, the function, is not true. So anything that you put into this function, it would always generate a false result. So let's get into the more complex ones. This one, ax. So let's see. So this means a universal quantifier, right? So for all values, the function ax is true. Let's forget about the not upfront. So if we forget about this, then this means this, right? However, if you put a not before it, this means not for all values of x, a of x is true, meaning that for some values, a of x is true, right? So this is similar to I'll be looking into more examples so it's better, so you guys understand this much better. So this is another example, and let's try to look into it. So every student in the class has taken CC 230 or CC 220. So let's represent this using a function. So P of x, let's say, is people taking CC 230, and Q of x represents people taking CEC 220. Right? Now let's try to quantify it. Always remember, to quantify any equation, we have to first put it into a function. So it says every student, so that means we're going to use a universal quantifier, as we are putting the values in x. So we put x here and put a bracket because it says or. And remember logic case, so or means this sign. So either CC 230 or 220. So 230 is P of x or Q of x, and we're done. As there is one more thing that you have to remember, which is like a convention that everyone follows, is that we can also write this like this: all students have taken CC 230, or this sign represents or, if you don't know that before, so that's why I'm writing it down. So or all students have taken CC 220. So this is also correct. However, if in situations where there are hundreds of ors, like 230 or 220 or 221 or 212, then you have to write a lot of stuff, and it would be really repetitive. So this is the best way you can do it, and this is the convention that everyone follows. So let's look at another example. So in this case, it says every student, so AX in class 6 or 7. So it says or, but we can't use this sign because remember, if you are in class 7, you have already passed class 6, right? It's not the case that you can do both class 6 and class 7 at the same time. And in OR, there is a situation that OR gates where both cases are true would generate a true value. So you can have, in the past example, you can be doing both 230 and 220 at the same time. However, in the next example that we are talking about now, you cannot do both class 6 and class 7 at the same time. So you have to be in any one of them. Thus, we are using an XOR. So let's say class 6 is P of x and class 7 is Q of x. So P of x XOR is represented by this sign, Q of x. Okay guys, that's all for predicates and quantifiers. I know this topic is kinda confusing at first, and the questions that come from here are quite confusing. So I would be covering 5 more examples that I had in my exams. So hope you guys like this video and stay tuned for the next one.